This is number 5 from the Stoichiometry I worksheet. I wrote down the equation for you down below here. It's got a lot of extra wording in it, and sometimes that intimidates people. So I thought I'd work through this one here on the video so you could see it. One of the things that it tells us when we're trying to go through and find what's the given, it tells us a temperature. That's just telling us we're not at STP. If we're not at STP, we can't use 22.4. So it tells us what to use instead. So STP, if you're at 20 instead of standard temperature, it would be 24.0. So those are just informational stuff. So in other words, the 60 grams of butane is our given. So we're going to write 60 grams over 1. Butane, it tells us over here, is the C4H10. So that's what that is. We're going to draw a conversion factor. Step 1 says to balance the equation, but it's already been balanced for us. So step 2, get our given to moles. So we're going to go grams to moles. Still talking C4H10. You can only convert from one substance to another substance in a mole-to-mole ratio. So since moles is with grams here, we know it's 1 mole. And then the grams would be the molar mass of C4H10. So I take the molar mass of carbon is 12.01 times 4. The molar mass of hydrogen is 1.01 times 10. Added together, I get 58.14. And that goes in for grams. Then step 3 says to do a mole to mole. So we bring that moles down here, and that was C4H10, because that's what will cancel with this. And then you have to go, as soon as you see moles on the bottom, that's your hint that you're going to moles of the other stuff. So we go back and we read the question. It says, how many liters of oxygen? So oxygen by itself in our equation is O2. And then for those, we go back to our equation down here. And O2 has a 13 in front of it, so we put a 13 on top. And then C4H10 has a 2 in front of it, so we put a 2 on bottom. And then we converted moles to moles. And then step 4 says to take that and get to whatever I ask you for. So we got one more because I asked you for how many liters. So we have to get to liters of O2. So since this mole canceled with this mole, this one has to come down. That's moles of O2. And we want to go to liters on top O2. We put a 1 with moles, and this is where we would normally put the 22.4, but because of this extra statement in our thing, it says it has to be 24.0. So put 24.0 there. Multiply the tops, multiply the bottoms, divide top by bottom, round to 3 significant digits. I get 161, which would be the same thing as 1.61 times 10 to the 2 liters of O2. And that's how you do number 5 on the Stoichiometry I worksheet. Good luck.